My second work that I will present now is called Determination of the Radioactivity Properties of the Plastic Film, PVC. We use a PVC film to analyze the properties of high radioactivity properties. The main goal of this work is determination of the transmissivity, reflectancy, and energy absorption in the form of a radiation through the plastic film. Plastic film is very common and not expensive, easy to manipulation, and can serve as support for analysis of the many materials, include liquids and granulates. To simplify the scheme of the radioactivity distribution of energy, we have an array of light that 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 comes into to medium 1 to 2. When the ray of light incident in the between middle 1 and 2 in their interface, some energy is reflected and another energy will be transmitted. The energy will be transmitted, some of them is absorbed by material and another part is transmitted. We have in this job this main equation that describes the behavior of the ray of light. One equation is the first equation that we show in this slide show the index refraction of the material is complex because they have attenuation. The complex number is because they have attenuation of the ray when passed through material. We have R film and T film. R film is the variable which analyzes all the energy which is reflected, and T film is the all energy that the sensor of the machine will learn will will capture will capture. We have the coefficient of extenuation of the ray, and and finally we have the the we have a way to find by the final form index of refraction of the ray. It's very simple. Our job is very simple. The first to analyze the transmissivity of the ray through material, we have a ray produced by the main source of the machine. The source emits some energy. The energy passes through material. Some of energy is absorbed, some of energy is reflected, but almost all energy is transmitted. The figure 2.A show the energy which is transmitted. The figure 3.B show the problem that we have a reflectance of the material. The figure 3.B show the paths of the ray through equipment to analyze how the material reflectance properties will behave. First, we have to analyze the length of material. We have, because of the material is very thin, we capture the information through electronic microscope. It shows that 10.5 micrometers. Another important information that we have from the equipment is the transmissivity. The equipment, almost 55% of energy of the ray is transmitted. It's shown by the same graph. And some of them is reflected. We show in this graph some peaks of the of the absorption because we have in the air uh, water in the state of vapor, and water in that state absorb some energy. To get the information of the properties of the film, we have to analyze through this formula above how is how is the property relation is related is linked by the energy. In the first, we have the total of the energy reflect this information is get from the machine, and we have the reflectance that is obtained by the application of the formula, the first formula. Another is the total of energy transmitted. This information is get from machine sensor, and the transmittance is get this information is get from the second formula it's shown in this slide. All radioactivity properties of the material. So from this all information we get all properties of radioactivity of material. It is very interesting to observe that almost energy is transmitted. Some energy is absorbed, but a very, very little is reflected. Almost nothing is reflected, and almost everything is transmitted. Another information that is very important is the extinction coefficient. We show in this picture some peaks. This peaks is because of the water. This is not possible in our machine. It's not possible to make it in the vacuum. And and from this graph, it shows that uh, some peaks and shows the absorbing coefficient, or in some books it's called the extinction coefficient. Now, and finally, we have the most important properties of this work. It's just get from index of a refraction, the real part. The imaginary part is because there is absorption in this material. And the real part is the energy, is show the amplitude of energy, is which is which is reflected by the material.